So in this video, I'm going to complete questions 13, 14, and 15 because for each of these questions, we are simply determining if the given equation is a linear equation in two variables. Now, remember, we've talked about in this class, in developmental algebra, we are only going to be dealing with and graphing and examining linear equations, meaning the equations we're dealing with create straight lines. There are no curves. So we are not dealing with parabolas, we are not dealing with circles or ellipses, we are not dealing with hyperbolas, nothing too crazy. We will get into all of that in future semesters as we get into higher levels of mathematics, but in this class right now, all we're dealing with are linear equations, straight lines. And we talked about in class that in order to be a linear equation, meaning if we were to graph the equation, would it produce a straight line? There has to be a couple criteria that are met. You might recall that we said that it's okay for the equation to just have an x variable. That's okay. Or your equation that you're dealing with may have just a y variable. That's also okay. More often than not, the equations we're going to be dealing with have both an x and a y. So your equation can have both an x variable and y variable. But what's really important, and maybe I'll do this in a different color, what's important is that the exponents on the variables are 1. So as soon as you see a variable that has an exponent greater than 1, you know that is not a linear equation. That equation creates some other shape that we will examine in a future math class, right? So whether it's intermediate algebra or maybe college algebra, pre-calc, something that is going to be in a future semester we will look at. But right now, if your equation has just an x variable, that's great. If your equation has just a y variable, that's great. If your equation has both an x and a y variable, that's great. Do the exponents on those variables, is it 1 or is it greater than 1? We're looking for those exponents to just be 1. So if we take a look here at this given equation, we have negative 9x, and I'm going to go ahead and write this out. So we have negative 9x is equal to negative 2y minus 8. So again, let's see. Does this equation just have an x variable? No. Does it have just a y variable? No. Does this equation have both an x and a y variable? Yeah, it sure does. So it meets that criteria, which is great. And how about the exponents on those variables? Well, we can see here that the exponent on this x is 1, right? There's nothing there, so it's automatically understood to be positive 1. And how about the exponent on the y right here? Well, again, there's nothing there, which means it's automatically understood to be positive 1. So the variables in this equation meet the criteria of being only 1 as its exponent. And so we can say then that this equation, if we were to graph it on a rectangular coordinate system, is linear. It does produce a straight line. So there we have question 13. I'm going to go ahead and get rid of this here and look at question 14. So let's go ahead, one question, and here we are. Determine if the given equation is linear in two variables. So we have been given the equation 2x equals 2y. And again, we want to determine, is this linear? If we were to graph this thing, would we end up with a straight line or some other shape? Well, let's see. Does this equation have just an x variable? Nope, it's got an x and a y, which is great. So it meets this criteria. And how about the exponents on the variables? Are they 1 or are they greater than 1? Well, again, we can see right here there's nothing written, so that's automatically understood to be a positive 1. And right here for the y, again, nothing written, so automatically understood to be a positive 1. So this equation meets the criteria to be linear because it has an x and a y, which is great, and the exponents on those variables is 1. So is the equation a linear equation in two variables? You got it. It sure is. It creates a straight line. All right, and last but not least, question 15 here. Let's take a look. All right, there's question 15. So we've been given 2x squared minus 8y is equal to 3. So let's see, is this a linear equation? If we were to graph this, would we end up with a straight line? Well, in this case, we have both an x and a y, so it meets this criteria, which is great. Let's take a look now here. The exponents on the variables are 1. Uh-oh, I see a problem here, right? Because if we look at the variable x here, what's the exponent? It's a 2. So as soon as you see one of the variables that has an exponent greater than 1, it fails the criteria here, and therefore this particular equation is not linear. Yes, the y exponent is a positive 1, which is great, but it's not enough for just one of them to meet the criteria. Both your x and y have to have an exponent of 1. Otherwise, the equation is nonlinear. So in this case, we are going to say no, the equation 2x squared minus 8y equals 3 is not linear.